Greetings folks and welcome to the Electromaker Show. This is your roundup of all things maker and embedded and lovely, where we look at fantastic projects, fantastic products, and some crowdfunding things that you may want to back if you're into very specific embedded electronics ideas and good vibes in general. Now, this week's show has a real plethora of nice projects, partly because we have the Electromaker of the Month winners for June. If you're not familiar, that's our rolling contest that gives the opportunity for anyone who puts their projects on our sites to win cash. We're also looking at a fantastic proof of concept that turns sign language into audio, just completely on the fly, offline, AI doing good things, and there's a bunch of other stuff to get through in this week's show as well. Just a warning ahead of time, this is yet another show where the attic of dreams is more like a furnace of, well, still dreams. So yeah, there's some sweaty moments where I do mess up words in this show, and I hope you enjoy my failings as much as I enjoy leaving them in the edit. All right, let's go. So, on last week's show, we featured the LilyGo T-Glass. Now, this is an ESP32-based development kit. If you'd like to know the full story, go back and watch last week's show. But my review of it has stayed more or less the same. I'm very happy I got this. The ESP32 with the battery built into this arm, which is connected to the glasses but can be disconnected, so you can just have the arm and use it for whatever you want. It's a wonderful idea, and the inertial measurement unit on it is top class. It has the AI-ready Bosch self-learning IMU. I'm still to really get my head around exactly how it self-learns, but it's something I'm looking forward to playing with a bit more. The only disappointment is, unfortunately, the main reason you would want to get these glasses, which for me at least, this prism display is not something that I can read, at least with my eyesight, which I think is pretty good, but I may be wrong. Now, the thumbnail for this episode has another set of wonderful glasses in them, although I don't actually have them here. The creative team made this amazing thumbnail that made me look like I was wearing the glasses, but it's actually a wonderful project from Coders Tech Cafe. They have made some sign language translating glasses, which do exactly what it says. Instead of a screen, it has a camera to take in the world around it. And if it picks up anyone doing sign language, it uses a Raspberry Pi Zero to send that to a cloud-based inferencing system, which will then speak that out in real time using a speaker built into the glasses. And this really is an astonishing proof of concept or prototype, because everything except power is in the body of these glasses. So from a very high level, this is a computer vision on Raspberry Pi project. There are many like it, but there are a number of really nice design decisions here. There's three main things I want to quickly cover, but I highly recommend, as always, coming and looking at this yourself. This is a full walkthrough of every single step you will need to replicate this project, and of course you can take little forks in the road here and there to make it your own, and make it do your own thing. There is also a video version of the walkthrough here that you can find in the body of this project, which will be linked in the description. But the first thing I wanted to talk about briefly was just the choice of materials for making this project. So this project uses a Raspberry Pi Zero 2W, and this is presumably for the form factor, because as you can see from the original image, it will fit into one of the arms of the glasses. There are probably other options you could use for this if you don't have access to the Zero 2W. I think they're widely stocked now and fairly cheap, but we can talk about that a little later. Another nice design choice is the idea of using a Raspberry Pi camera module version 2, because there are much better camera modules out there at this stage, but you don't necessarily want that if you're doing computer vision, especially on low-powered hardware, because the huge amount of pixel information that you get in at every frame is wasted. There's no way you can process that much on smaller hardware. So this is actually probably a really perfect choice for this, depending on light levels, I assume. So once you have a way of capturing images and putting them onto a hard drive, putting them into the memory of the computer, you need a way to then convert those images into speech, because that's the whole idea of this. Anyone wearing the glasses should be able to watch sign language and then have it spoken to them from the onboard speaker. And the way they got that working is by using a USB sound card, which was a bit chunky in its original form, so removed all of the unnecessary parts that they did not need, and paired that with a little, well, this little speaker and this little power amplifier board. And again, they're all very small and very nice, and if I scroll down just a little bit, you can see this is some of the installation instructions, which are fantastic, by the way. You can see how they've actually made this all work and fitted it together. Essentially just putting all of these things directly onto the Pi Zero. You can see this is the USB sound card just here, and on the other side is the power amplifier here. And as you can see, this fits really quite well into the 3D printed case. These two images show everything in their places. The camera in the center of the glasses, looking directly the direction you will be, the Raspberry Pi Zero with all of the audio stuff attached to it, and the speaker in the opposite side, so that you can actually hear what is being said to you. So with the hardware assembled, that brings me on to the second part of this, which is how do you actually turn sign language into something that is recognized and then spoke back to you? Well, you could go absolutely old school and from the ground up learn how to train your own neural network on your own computer, but like so many things these days, there are different ways of doing it. We've talked a lot about Edge Impulse on the show in the past, and this uses something that as far as I can tell, it's the first time I've come across VIAM or VM, however you pronounce it, but it's a very similar kind of idea, although it does have a lot of really nice inbuilt stuff that allows you to, for example, if you're an enterprise customer, run whole fleets of AI-powered devices, all connected via the VIAM server on the device to the main center VIAM app that you have. So it kind of combines a few ideas, but basically in brief, VM allows you to collect data and then train that data in the cloud. And then once you have that model that you've trained in the cloud, you can then deploy that onto your device. And at that moment, it is completely offline. You do not need to be connected to the VM server anymore, at least as far as I understand. The use of offline models is completely free with no barriers or any kind of payment plan. What you pay for with VM is the amount of training data that you can use. So say you wanted to put up to 10,000 different examples of sign language into it to get your model out again, then that wouldn't cost you anything. That fits within their free tier. But as soon as you go above that, you start paying on a sliding scale. So if you wanted to use this for work, for example, it might be worth taking a look at their pricing. For hobbyists, it's really good because it allows you to try these things out and come up with wonderful prototypes like this. So I will leave a link to VM in the description. I spent a little bit of time just looking over some of the basic things. Now, one of the things I did want to come back to just before the end of this is that this project in and of itself is wonderful. But one of the things I get asked relatively frequently when I do cover projects like this is how could I do it with X board or Y board? Will it work with Z module? And the answer is almost always yes, with a few caveats. So in the example of this one, for example, the installation guide here says essentially this should work with any Linux 64-bit operating system running on the AArch64 or x86-64 architectures, which is a pretty wide variety of boards. And there are a bunch of boards here that are kind of specifically set up with guides for those boards, but if you are able to follow the Linux installation for it on any kind of machine that you have, say one of those little Raspberry Pi Zero clones, although they're not clones, they're alternatives, then you can absolutely get that going. Of course, RISC-V is a whole other kettle of fish. Who'd put fish in a kettle? They boil. Anyway, fish and kettles aside, this is a wonderful project in and of itself. Coders Cafe Tech deserves the props and praise for putting it together. As I've mentioned a couple of times, everything is within the body of these 3D printed glasses except from the power, and as you'll see if you look in the project, they just have a power bank that they can put in their pocket. But this kind of project really represents something very exciting to me as well. Because when you think of AI, a lot of the time it's the huge headlines that generative AI is going to destroy humanity and all these iconoclasts are talking about it, and it sort of feels very out of our hands, right? But this stuff is in our hands, on our workbenches, cheaply available, and thanks to things like Edge Impulse, or in this case VM or VIAM, you can get started for free making whatever you want. Cleverer using AI that will work in an offline way. And you could convert this to use anything. And as mentioned, you could also convert the hardware using it. An example being a compute module instead of a Raspberry Pi Zero would add a level of complexity to it, yes, for sure, but it would also add a massive boost in processing power. You could put that into your idea here. But for things like medicine and accessibility, AI is already starting to make its way into those fields in a way that is fundamentally useful to people. The way data is collected is changing in this very moment all the time. And something like this, for example, I mean, if there was a commercial product that allowed sign language to be in real time translated into people's ears, that would give accessibility to people who have to use sign language as their primary form of communication to a much wider group of people. The crossover between certain kinds of specialists and people that can actually use sign language is brief, which means that you which means that you have to always have a translator there. This could really open up a world for a huge number of people, and I really love seeing AI projects that do that. But yes, anyway, that's enough soapbox Ian for this moment. There will be links to this project and VIAM or VM in the description. I do hope you give it a look. It is a really, really nice one. It is time for our product of the week, and this time we are talking about the Adafruit 9DOF Breakout board that allows you to get absolute orientation measurements without having to do a lot of the legwork you usually would have to do with an inertial measurement unit. Now, we'll be looking at the wonderful article and video that Robin has made in a moment, but yeah, I am a big fan of the way that these Breakout boards are made, partially because the part on them, which is one of Bosch's many amazing low power measuring units, it's a MEMS accelerometer, gyroscope and positional unit in one. That part is incredible, but also just because of the way Adafruit works. If you get one of those Adafruit modules, more often than not, you don't even need a soldering iron in order to use it. You can just connect to the stemmer connector on the board, and if there is a stemmer connector on your Arduino or whatever board you're using, you can use that, or you can usually get a very easy pin-to-pin shield for setting those things up as well. If you have a Grove Arduino, you're already sorted because stemmer, Grove, and Sparkfun's Quick are all more or less interchangeable, so you don't need a soldering iron for this one at all. Anyway, that's enough pre-waffle from me. Let's see what Robin had to say about it. And perhaps unsurprisingly, Robin is saying much the same thing that I just said in that intro, but with a lot more technical detail, because he is an engineer and he is someone who talks about this stuff in an educational format, at least partially, for a living. But yes, this board, a couple of things he mentioned that I forgot to mention. Power management is all taken care of on top. You can plug this into most development boards and it'll just work out of the box. And the information it'll give back to you is pre-filtered. You don't need to think about any of that. You just get back the values that you need, which makes it fantastic. Now, one thing I haven't mentioned so far is how much this thing costs, and I know people get at me for forgetting to say that. It is $30 for the unit, which is incredible. It's a steal. For a 9 degrees of freedom orientation sensor that gives you everything out of the box, that's incredible. And it is also very easy to use. You can program this directly. It has its own SDK and way of talking to it, but there's Arduino libraries for it. You can also use CircuitPython, MicroPython. There's a bunch of different ways you can work with it. And if you are working on Raspberry Pi as well, there's a bunch of nice little features with the Pi IMU library that I will link in the description if I remember to, which is just a nice catch-all library that covers most modules, but especially the BNO 055, which is what this is based on, is well represented there. If you're working with I2C, no problem. You can also work with this with SPI, as far as I know. But anyway, rather than spend more time than we should talking about it when we have this fantastic video from Robin, I would suggest heading over to this link. You'll find it in the description of this video, watching the video from Robin, and you can read through the article. And if you would like to get a hold of one of them, now would be a perfect time to say, if you buy it from us at the Electromaker store, it will directly support what we are doing here on the show. We do not turn on any form of monetization on YouTube. If there are any adverts before or after your video, that is something that YouTube is doing presumably to make money for itself, I guess. We do not turn monetization on. We have a shop instead. So if you would like to support us, that would be wonderful. If not, clicking like on this video, making sure you are subscribed, maybe turning the notifications on so you see when things come from us. That would be fantastic. And leave a comment, not just because of algorithm stuff, but because that would be very, very nice. I'd love to hear what you think of the show. I'd love to know what you're working on. In fact, in the past, some of the awesome things that I've discovered and ended up putting in the show came from people talking about them in comments on previous videos. So yes, I'm very much open to hearing what you think in the comment section, just for vibes, but also because, yeah, it helps with YouTube stuff. It does. We are very crushed for time, but I'm going to sneak in a very quick funding website. Things over on CrowdSupply, the Conexio Stratus Pro is the first development board I think I've seen out there at all featuring the NRF 9161, which is Nordic's updated cellular IoT chip, which in short allows you to do a lot with a very little amount of power draw. Now, straight off the bat, if you're wondering what the differences are between the NRF 9160 and the NRF 9161, there is a fantastic chart in the dev zone that I believe Martin Lesund, am I correct? Yes, Martin Lesund from Nordic left a nice chart in here talking about all the different parts. I think we have looked at this before simply because this is where I first noticed the words Nordic 91, Thingy 91X. Before they'd even announced it, before we knew about it, before any of that, I noticed that this was here because this is ending up in the new Nordic Thingy 91X, which is going to be available rather soon. However, the NRF 9161 adds a couple of extra things, including DECT NR Plus connectivity and a few other things that I will not go into now. If you're interested in the difference, link in the description to this very chart on this very site. So I'll keep this relatively brief, but as far as dev boards go for low power IoT, this is pretty much set up for everything that you will need. And that is because it has the Nordic backing. We've talked lots on the Electromaker Show about the fact that Nordic pretty much have put all their eggs in the basket of really good connectivity and quite a lot of power, but with a very low power draw. And if you look at the sort of things around their flagship products, it makes sense because their NRF9161 is, a flagship system and package for cellular IoT. But what really makes it work well is the power management that goes alongside it. And again, there's an interview at Embedded World. It's under last week's video, I think. I'll put it in the description of this one where we talk about their power management stuff. You can find out more about it there. But everything that we talk about, including the fuel gauging and all that kind of stuff, is available to you on this little development board. So this is definitely for people who are looking into getting into low power cellular IoT. It's in the feather wing form factor, so we'll work with all of the add-ons, all of the capes, I think they call them. Or is that? No, that's Pocket Beagle. Whatever the feather, maybe they call them the wings. It's a feather form factor board and it'll work with all of the feather wings. But it also has a stemmer connector, a quick connector, which is the same thing as a stemmer connector. I think you can very easily convert them to be Grove connectors as well. The point is it has a solderless module connector just on here. And it allows you to do all of the things that you would do with a Nordic development board or any other IoT-based development board, but with a few nice features. So, out of the box, you get a SIM card, which comes with 500 megabytes of IoT data, 250 SMS messages, valid for 10 years, no strings attached. So, while you are learning how to use all this stuff, you're not going to spend any money on the network side of things, probably, unless you go over that 500 megabytes of IoT data allowance or send more than that many messages. By the time you do get over that line, I imagine you'd be happy to pay for it because it's something that you would be either using for yourself and have made a very nice DIY product, or looking into going into production, and that's just going to be a production cost anyway. You also get all of the same kind of support as you would with any other Nordic development board. So there's a bunch of Visual Studio Code plugins for the NRF Connect SDK, which is based on Zephyr, and you can plug in and use it exactly as you would with any others. The difference being, I think you can program directly through the USB port, and you're doing it all on the one development board, of course. So the full features and specifications are available here. If you'd like to find out more, you can come here. There's a very nice chart as well. And as mentioned, the main thing, the main difference with the NRF9161 is there's a few improvements. It has a wider bandwidth, and it is now DECT NR Plus ready, if that is something that you are wanting to put into your project. And if you would like to get your hands on one, they are available now for $89, but they won't be shipping until September of this year, which is pretty much how everything works on Crowd Supply. They are very good at helping people get things to market and very good at helping people have a manufacturing plan by getting things out ahead of time, in that you take the pre-orders and all that kind of stuff. It allows you to make assurances about how things will come out. And I have never heard of anyone being burnt on Crowd Supply in the way that you can on Kickstarter. And that mostly comes down to the vibes. As I mentioned when I came back from Teardown, the folks at Crowd Supply genuinely want to help people make good things. And I think that shows with the quality of the stuff that comes out of the site. Before we finish here, I want to give one quick shout out. As so many projects on Crowd Supply have, there's a comparison chart here. And the Conexio Stratus Pro pretty much just greens across the board. It's showing that it is, it has the newest tech inside it, and it is worth every penny of that $89. But I do want to give a quick shout out to CircuitDojo and the NRF9160 Feather, which is another feather form factor board, which has the NRF9160, which was the previous flagship system and package for cellular IoT from Nordic. CircuitDojo has some of the best and in-depth streams and videos on his YouTube channel for how to learn about Zephyr. And as someone who is really trying to get his head around it, his Zephyr 101 video series are very informal chats, which are very well prepared. He has slides and all this kind of stuff, but they're just piece by piece going through how to code various different things using Zephyr. And here is the NRF9161 Feather as well. So if you're interested in that, I wanted to give a quick shout out. I know that's got nothing to do with the Conexio Stratus, but I noticed his name when looking at this page. Someone I've probably shouted out once before, but if you are like me, learning Zephyr the painful way, piece by piece by piece, he's a wonderful resource. However, back to the Conexio Stratus Pro. I don't like giving absolutes because it seems silly. There's so many wonderful things out there. I have not seen in my research for this show another small form factor development board that gives you as much control over cellular IoT and the power you use and the way that you can control all of your data flow and power flow as this development board. If it's something you're interested in, I would highly recommend taking a look at it. It's time to look at the winners of the Electromaker of the Month contest for June 2024. This is a rolling competition we've been running where we take every project that is submitted to the Electromaker Project Hub in a particular month and send them to a panel of independent judges. They will pick a top 3 to win prizes, and thanks to our generous sponsor Koitech, those prizes include cash and a big pile of swag, and also there's a bunch of Electromaker swag goes into it too. First prize wins $150, second $100, third $50, and everyone wins a bunch of branded stuff from us and Koitech. And you don't have to do anything special to enter these contests, it's just every project that's put up onto our hub, and you can do that with a free Electromaker of account. Electromaker of account? A free Electromaker account. Now, I'm not going to spend an awful lot of time going through these projects on the Electromaker Show right here. I would advise you to look at the link in the description to this blog post, which has a roundup of each 3 of these projects and a link to the projects themselves if you'd like to get into the real details of it. But to give a brief overview, our first place winner was this ESP32S3 Power Feather demonstration, which was a documentation of how the Power Feather can work in order to do full power profiling on your projects. So the power wing that this project is showing off is quite an interesting prospect. It is a feather wing board, as the name may suggest, or feather wing form factor board, set up from the ground up to combine power monitoring with the Internet of Things and connectivity, hence the ESP32 and the power monitoring circuitry on board. This allows you to set up triggers for actually communicating over a network based on certain kinds of power charge, but it also allows you to do some very fine-grained checking of how much power your project is using. It has a very nice built-in browser-based dashboard as well that you can use. There's a lot more to be said about this, but I'm going to keep it brief because we have other things to look at. But yeah, I'd highly recommend coming and having a look at this project. I'll remind you that the reason that this is in first place is that the judges are basing their judgment on documentation, and this documentation is absolutely fantastic. So if you'd like to find out more about battery monitoring in general and power monitoring, this is a good article to look at. But it's also, yeah, the Featherwing, like I said, very interesting prospect and one I'm sure we'll be hearing more of in the future. So congratulations, Power Feather. I do believe that you're a one-person team. I might have that wrong, however. But yes, well done. You are the first prize winner. You win $150 thanks to our sponsors Koitech. You'll also be getting a big pile of swag from us and Koitech as well. We will be in touch with you as to how we can get it out to you. So let's move on to second place. And second place is my personal favourite, although as I've said many times before, I'm no part of choosing the winners for Electromaker of the Month, which is a wonderful thing. It allows me to just enjoy all of this kind of stuff without having to judge it, and this is making music using low-powered microcontrollers. It is the thing I love the most about this entire hobby and industry, so of course this is my personal favourite. The Wave Trigger drum machine takes a couple of very easy-to-get components and an Arduino Nano, the OG ATmega328P, and turns it into a very functional polyphonic drum machine. So the principal operation is quite simple. You use the OLED menu to choose a different sound for each MIDI note, and then you can plug in using a TRS MIDI jack in order to control it, a little like this. So on the surface, there's a great simplicity to this, and that is actually a good thing. Don't get me wrong, I love huge, complex Eurorack modules and synthesizers that you can do 1,000,001 things with, but the way this works is simple and to the point. You put MIDI into it, and it will play drums out of it via the left and right channels, and you can also send one of those drums out via a sidechain channel. So if you wanted to sidechain it to duck out the bass or duck out synthesizers or whatever, you can do that. And if you watch the example video that is here that we were listening to just before, it will show you actually it doing that in real time. If they plug the sidechainer in and then turn the compressor up, you can hear that the synthesizer is ducking in and out based on that kick drum. Now, behind the scenes, there's essentially 2 main parts to this. One is an Arduino Nano with the original ATmega328P chip in it, which is being used to control a WAV trigger. Now, there are multiple different types of these, but this is sort of the best known one. It's the one Sparkfun put out a little while ago. It's still available for around $55, and it allows you to play WAV files off an SD card, but crucially, it allows polyphony. So if you have, say, a bunch of files on that SD card, it will allow you to play 14 of those samples on the SD card simultaneously, giving this drum machine 14-voice polyphony, which is very handy because if you ever tried to make a drum beat, you sometimes want your hi-hat to hit at the same time as your bass drum or your kick, or your snare, sorry. And this allows you to do that with up to 14 voices, which is quite a lot. And this is being controlled via the Arduino Nano, and you can set up the Arduino Nano to save things on its internal EEPROM, and that's exactly what this project is doing. It can save things into the internal EEPROM like different kits that you have. You can save up to 10 separate kits that you can just pull up with a touch of a button on the menu here and have those kits ready to go, presumably switching between them while you are playing a performance if you want to. This is all something that comes together with, apart from the WAV trigger, which costs a little bit more, stuff that costs well under $10 to get all of the parts you need. If you are interested in finding out a little bit more about it, the full write-up of how it works is here on the Electromaker site. And also, if you click out to the YouTube channel of the video itself, which is Rob Muru, you can find the GitHub page here just as well. And actually, if you are signed into the Electromaker site, you can get it down here too. I just realized on this particular account that I use for filming the show, it's a completely separate browser to my own one. So when I click on this, it asks me to join Electromaker. I should probably get around to doing that. But yes, you can find the schematic as well here on the GitHub page, which is under the YouTube video, and that is embedded into this project, which I will be linking in the description of this video. But I am a huge fan, as I've said many, many times, of people making their own DIY music making devices, and this is the perfect example of the right scope, a simple project, but that comes out as something incredibly usable. I just really love it. So huge congratulations to MechSpare, but you win second prize this month for the wonderful module I've just been waxing lyrical about. Also, Rob Muru on YouTube. Head over to his channel and drop him a subscription. Now let's move on to third place. And third place goes to Gus Gunnett, who's put out a series of different tutorials recently, actually, all focusing on using various different things with the particle photon, which is a development board I'm not as familiar with. But all of these things are very interesting because they integrate with Shelly devices. And friends of mine who are very deep into their home automation and smart home stuff always sing the praises of using Shelly devices for power management and shunting things on and off and in their lighting systems, all that kind of stuff. This one specifically, however, it was for the BLE door and Windows Alerts project. So in essence, this is a project that combines a Bluetooth low energy equipped sensor and a particle photon board and the particle webhooks system, which is something I am not familiar with, but the form factor of it is something that I have seen many times before, and I'm sure watchers of the show will know it too. And in fact, let's start there. What this is actually doing is creating a webhook which will link that sensor pinging information off to an action. And in this particular case, it is sending a notification. That notification is, has this magnet been open for more than 2 minutes? And if that's the case, you get sent a notification. It may be a sign that someone has opened your door surreptitiously, or it may be a sign that you've forgotten to open or close a window. And of course, remember, there is a level of granularity in this. If you know you're going to be leaving the house and you want to set up some kind of vague budget security system, you could set it so that if you know you're going to be out of the house and nobody's going to be going in, it could send you a notification the second it detects a door or window opening, for all the good that it may do you. But at least I suppose you could call the police and say, I think someone's breaking into my house and I'm not there. The notification system is called Pushbullet. Once again, something I've never had my hands on specifically, but this is a web service that will allow you to send notifications to your phone. And if you would like to find out more about this project, do head through and have a look at it. As I've mentioned earlier in this section, the Electromaker of the Month is a documentation-based project, and this project takes you through every step of how you can make this thing work yourself. And as I also previously mentioned, Gus has other tutorials based on a very similar kind of idea. If you're looking for very low barrier of entry ways to get into setting up your home and making it more smart, this might be a good place to look. So congratulations to Gus Gunnett and the other two winners this month. Gus, you'll be getting $50 and the big pile of swag we already talked about. And thank you for Koitech for sponsoring this and being able to allow us to give cash prizes to people for doing this. It really is an amazing thing to be able to look at all of these projects, and I very much look forward to seeing what everyone comes up with in the future. The Project Hub is open to all. If you have a free Electromaker account, you can just click upload your projects here. We have a very simple step-by-step process in the browser you can use to add pictures and the story and all of the bill of materials. You can even import them from other websites if you wish. We have a real big turnover of loads of people putting projects up on here, and this is my favorite part of Electromaker personally. I really do enjoy looking over and talking about all of the projects you folks are making, so please do keep them coming. That has been the show for this week. Thank you so much for joining me. Thank you for your continued support. Thank you for your patience as I stumble over words in the 35-degree heat it is up here. At least it was 35 degrees when I started. I can't actually see my thermometer from where I'm standing at this particular moment. But yes, it is significantly hotter in the attic. Who'd have thought that a room at the very top of a set of flats would get absolutely oven hot in the Berlin summer? But yes, I mentioned it earlier in the show, but I'll mention it one more time. If you would like to support us, the Electromaker store is the best way to do so. Conexio. That is electromaker.io/shop. We have everything Arduino, Raspberry Pi, everything from Sparkfun, Adafruit, like the thing we featured in the product of the week this week. If you'd like to get anything from us, that will support us directly. Although, of course, just pressing like on this YouTube video and making sure you're subscribed to our channel is much appreciated as well. I look forward to putting the next show together and sharing a bunch of other fantastic and interesting things with you. But for now, I hope you have a fun, safe, and creative week, and I'll chat to you soon.